So I had been asked to do some further questions and examples prior to the quiz that we'll have on Monday. And so that's what we'll be doing. We'll kind of work through some problems that will be similar to what you would expect on the quiz and similar to your homework, and that would be good to review before the quiz on Monday. So the first question we'll kind of go through and is dealing with scientific notation. And so it asks us to write this number in scientific notation. So what I would do is just rewrite the number. And then after writing that number down, I would write where that decimal is. And so remember, when we use scientific notation, our coefficient needs to be between 1 and 10. And so 1 and 10 would be 6.8. And so we need to get the decimal in between the 6 and the 8 and count how many spaces we need to move over. So that would be 1, 2, 3, 4, 5, 6, 7, 8. And so that would give us 6.8, and that would be times 10, and the power would be how many decimal places we had to move over. And we moved over 8 places. And because we went and moved the decimal to the left, and because our number is greater than 1, it would be a positive exponent. And so it would be 6.8 times 10 to the 8th. The second question is asking how many significant figures in this number. And so what we can see here is that we have 208, and that 0 is in the middle between two non-zero digits, so that 0 is significant. It's a sandwich 0, so it's significant. And then we have these numbers that are written after a decimal place, but before any non-zero digits. So these zeros are insignificant. So the only significant ones is the 208. And so we have 3 significant figures. Another way that you could think about it is as if we could write this in scientific notation. We would write this as 2.08, and we would have to move that decimal 1, 2, 3 spots times 10 to the minus 3. And so we only have 2 significant numbers. In this question, we have an addition problem, and we have to solve this equation. And then also, when we solve it, we need to write and use the correct number of decimal places. And so what we first want to do is we first want to write this in vertical notation, so 2, 6, 1, 0. And we want to make sure we line up all the place marks. So then plus 11.7, then plus 0.22. Okay? And so we get 2, 6, 2, 1.92. When we do addition and subtraction, we have to report the least number of significant the number that's furthest to the left, or decimal places furthest to the left. And so we just kind of chop it off here. And so we chop off our number right here. And then our number after the decimal is a 9. And we have to round it up. So we would have 2622 as our final number. Here is asking us to solve this equation using the correct number of significant figures. So in this question, we can just plug this into our calculator as is. So 26.1 times 11.7 divided by 0.22. And we get a very large number of 1,388.045 Let's keep it there. And then with the correct number of significant figures. So when we do addition and subtraction, when we do multiplying and dividing, we can only report the least number of significant figures found in the fewest number of significant figures found in any of the values that you are using. And so that would be here, where we only have 2 significant figures. So we would only be able to report number to those digits. So we would have 1, 4, and round, because we had to round the 3 up, 0, 0. And since we do not have a decimal point, then those zeros are insignificant. Here, it's asking us to find the density of a liquid that has the volume of 34.6 milliliters and a mass of 46 grams. So, density is equal to mass over volume. Our mass is equal to 46.0 grams, coming from here. And then it says a volume of 34.6, so V is equal to 34.6 milliliters. And so mass goes on top, 46.0 grams, divided by 34.6 milliliters. And when we plug this into our calculator, we get 46 divided by 34.6. We get 1.329 and other digits. And then each of these numbers has 3 significant figures, so we can only report 3 significant figures in our final answer. And so we use those 3. That number here is greater than 5 or greater, so we can round up. So we get 1.33 grams per milliliter. Okay, our next one is another density question. It says, what is the mass of a 53 milliliters of ethanol, which has a density of 0.79 grams per milliliter? And so we want to first recognize our units. Mass is equal to 53. Oh, no, look at me. We're looking for the mass. So mass is our question mark. It says we have 53 milliliters. Volume is equal to 53 milliliters. And then we have a density of 0.79 grams per milliliter. So we can do this 2 ways. We can do density is equal to mass over volume. And then we don't know the mass. And so we can just put our numbers in. 0.79 grams per milliliter is equal to m over 53 milliliters. And then we could cross multiply, and we would get a value of, so if we cross multiply, we get 53 milliliters times 0.79 grams per milliliter. We get 41.87 grams. Both of our numbers that were given or reported only have 2 significant figures, so we may only report 2 significant figures, so 42 grams. I'll show another way how you can do it. Would be using those same values. We could use the triangle method. So in the triangle method, we have D is equal to M over V. Mass is on the top of there. So mass would go on the top there. So since mass is in the numerator, mass goes on the top of this pyramid or triangle. And then D and V go down on the bottom. All right, whatever two values are multiplied, you put on the bottom. Since we are looking for the mass, we cover up the m, and it's d times v. So d times v was equal to 0.79 grams per milliliter times 53 milliliters. We get the same thing, so that would equal to 42 grams. So that's just an alternative way that may be helpful. That's the same question. And the last math problem that we will try is a temperature question. So the temperature of liquid nitrogen is negative 196 degrees Celsius. What is the corresponding reading on the Kelvin scale? So remember that Kelvin is equal to degrees Celsius plus 273.15. So our degrees Celsius is 196, so that's equal to 196 plus 273.15, and so we plug that into our calculator, and we get 469.15 Kelvin. And so hopefully that will be helpful to you on the quiz. So those are just some of the math problems that you might have to work out. You may also have other questions dealing with some of the concepts in the chapters. So just make sure you review the slides, and make sure you review the video of the lecture, and read through your textbooks. And so we'll see you on Monday.